Welcome to Formula 1 Maths again. This is exercise 1.3 for pure maths, GCE A-level, year 1. We've got 4 questions to answer. Question 1. A. Find the value of 81 raised to the power minus a quarter. B. Simplify x squared brackets 3x raised to the power minus a quarter, all of that raised to the power 4. So for question 1a, you will need to rewrite the 81 as a power of 4. Because I'm looking at this quarter here, and I know that if I write 81 as a power of 4, we can simplify it easily. So now I'm going to use the roots of indices, specifically a to the power m all raised to the power n equal to a to the power mn to simplify this part. So if I do that, then I'll get this using this rule here. We can now reduce the fractions. 4 goes to 1, 4 goes to 1, and I'm left with 3 to the power minus 1. But 3 to the power minus 1, using this rule here, a to the power minus m is equal to 1 over a to the power m. We can write 3 to the power minus 1 as 1/3. For b, let's simplify what is in the brackets here. So here, the 3 will be raised to the power 4. So the 3 raised to the power 4 will be 81. And then we use this rule again to simplify x to the power minus quarter, all of that raised to the power 4. And then we're going to get something like that. So now we can cancel 4 into 4, 1, 4 into 4, 1, and so I will be left with x to the power minus 1. So this can be written as x squared times 81 times x raised to the power minus 1. But the x squared times x to the power minus 1 is the same as x to the power 1 because they've got the same basis. We can add the powers. So we can write the complete answer as 81x. Question 2. Simplify 5 minus 3 root 5 over root 5 minus 2, giving your answer in the form p plus q root 5, where p and q are rational numbers. All what we do here is to multiply both numerator and denominator by the conjugate of this one. The conjugate of root 5 minus 2 is root 5 plus 2. So we go and multiply the numerator and denominator by the conjugate, and then we get this. So we multiply out. So 5 times root 5 is 5 root 5. 5 times 2 is 10. Minus 3 root 5 times root 5. This will be 3 root 5 times root 5. These 2 here will give 5. And so the full answer will be 15. And then we multiply root 3 root 5 by 2 to get 6 root 5. And so the numerator will be that. The denominator is the difference of 2 squares. And let me remind you, you've got a minus b times a plus b. That gives a squared minus b squared. So root 5 squared is 5 and 2 squared is 4. And so if you simplify the top and collect like terms, you are going to get minus 5 minus root 5 over 1, because 5 root 5 minus 6 root 5 is minus root 5, and then 10 minus 15 is minus 5. And then this will be the same as minus 5 root 5, and that is the final answer. So in this case, you can see that the p is minus 5, and the q is minus 1. Okay. Question 3. Using algebra, find all the real solutions to the following equations. First equation, A, 4a squared is equal to square root of 2a. B, m to the power 4 plus 4m squared minus 12 equals to 0. For A, the best thing to do is to square both sides of the equation. And when we do that, we get 16a to the power 4 equal to 2a. Then you divide both sides by 2 to get 8a to the power 4 equal to a. And then you move a from here to that side. And so you can factorize a out to get a brackets 8a cubed minus 1 is equal to 0. And then we have the first solution as a equals to 0. And the other solution will be 8a cubed minus 1 equals to 0. So when we solve that, that will be 8a cubed equals to 1. That means a cube is equal to 1/8. And then we find the cube root of 1/8. And that will give us a half. So the first solution is a equals to 0. And then the next one is a equals to half. For B, we will say let y equals to m squared. Then this whole equation can be written simply as y squared because we are saying that y is equals to m squared. Therefore, m to the power 4, which will be the same as m squared, all of that squared. So if we say that y is equals to m squared, then m to the power 4 will be y squared. So we can write the equation as this. Then we can factorize. How do you factorize this? We look for two factors of 12, which will add to give us 4. So we know that we have 6 and minus 2. Because 6 times minus 2 is minus 12, as you can see here. And then 6 minus 2 is 4. So we can go and factorize to get it. Then we solve for y by saying that y plus 6 equals to 0 or y minus 2 is equal to 0. So if you solve for y now, you're going to get y equals to minus 6 or y equals to 2. Now we introduce y into this equation, so we have to get rid of it. But going back to m, it means that our m squared is equals to minus 6 or m squared is equals to 2. But look, m squared can never be equal to 6 because a square number can never be negative. So we write this and then we ignore that answer and go for the answer that is valid. So this one here is not valid because no square number will give you a negative number. So the valid answers will be m squared is equal to 2. And then we find the square root of 2 to get m. So we're going to get plus root 2 or minus root 2. And so that's the answer for question 3. Question 4. Solve the equation x root 3 minus root 27 equals to x. Write the answer as a set in its simplest form. For B, solve the equation 4 to the power 3x minus 2 is equal to 1 over 4 root 2. So for A, we've got that. We need to rewrite this by doing this. So root 27, we know, is equal to root 9 times 3. But root 9 is 3. And then we have root 3 over there. So root 27 can be written as 3 root 3. So put that in there to get it. Then collect like terms. So I'm going to take x to this side and take minus 3 root 3 to this side. And I'll get that. I've done that because I need to solve for x. I need to isolate the x. So I can factorize the x out to get x brackets root 3 minus 1 is equal to 3 root 3. Then because I'm looking for x, I'm going to divide this by that. And then I'll get this one here. All I have to do now is to rationalize the denominator by multiplying both numerator and denominator by the conjugate of root 3 minus 1, which is root 3 plus 1. So we do that, and then we multiply out. So 3 root 3 times root 3 will give us 9, because 3 root 3 times root 3, again, that is 3 times 3, and that's 9. And so I'll get 9, and then 3 root 3 times 1 is 3 root 3. So I'll get that. We already know how to simplify the denominator, which is a difference of 2 squares here. We've done one before. So that will be this squared minus that squared, which is 3 minus 1. And so simplify that, you're going to get 9 minus 3 root 3 over 2. You can go and write it in the simplest form by doing this. So we get 9 over 2 minus 3 over 2 root 3. So that's A. For B, the best thing to do is to write this as a power of 2 and write the denominator here as a power of 2. We simply know that this as a power of 2 is 2 squared. But how about this one here? So we have 4 times root 2. We can write this as 2 squared for the 4 times 2 to the power half for the root 2. And because the bases are the same, we add the powers, and we are going to get 2 to the power 2 plus a half, which will be the same as 2 to the power 5 over 2. So now we can go and do this. And then we multiply this and that using this rule here. A to the power m raised to the power n is the same as a to the power mn. And so you're going to get this one. But we can bring 2 to the power 5 over 2 to the numerator by using this rule here. So if I have 1 over a to the power m, this is the same as a to the power minus m. So we can use that rule here, and we are going to get this. The reason why we did this is because we want to get the same bases. So this base and this base are the same. The powers must therefore be the same. So we go and equate them. 6x minus 4 is equal to minus 5 over 2. Then to solve this, the best way to do it is to multiply every term by 2. So this term by 2, this term by 2, and this term by 2. So I'll do this times 2, this times 2, and this times 2. And you can see that this will cancel. And I get a very nice linear equation, which is 12x minus 8 equals to minus 5. Then this is very easy to solve now. So we have 12x is equal to minus 5 plus 8. Then 12x is equal to 3. To solve for x, you need to divide 3 by 12, which is that. Then simplify it to get 1/4. Yes. So this is the end of this set of questions for exercise 1.